Hey everyone, thank you for joining today's Pitt Health Sciences Virtual Health Academy. My name is Katie Gertis. I am the Director of Alumni Relations within Health Sciences at the University of Pittsburgh. Today, you will be hearing from Dr. Hooman Rashidi on the state of AI within the University of Pittsburgh School of Medicine, current efforts, and future directions. Before we get started, I would like to make a quick reminder. If you have any questions you would like to ask, please utilize the Q&A feature, which is available within the platform, and we will address all questions at the end of the presentation. I would also like to take a moment to formally introduce Dr. Rashidi. He is currently the Associate Dean of AI in Medicine, Professor and Endowed Chair of Lombardi Shinonizuka Experimental Pathology Research at the University of Pittsburgh School of Medicine, Executive Director of Computational Pathology and AI Center of Excellence, and the Executive Vice Chair of the Computational Pathology Division at UPMC. He is also Adjunct Professor of Engineering at Carnegie Mellon University. Dr. Rashidi is also a practicing physician, board-certified hematologist, and a well-known educator with numerous teaching awards. He is also the co-founder and senior editor of Hematology Outlines, a very popular digital hematology atlas that is used internationally and endorsed by the American Society of Clinical Pathology. So without further ado, I would like to pass the floor over to Dr. Rashidi.
Thank you so much, and thanks for the kind intro. If you don't mind, I'm going to share my screen and go from there. If you can just let me know if the screen came through okay. And if it's, does it look okay and you can hear me okay?
Yep, that's all set. Thank you.
Okay, terrific. Well, thank you so much for the kind intro, and thank you all for joining us. So I figured in the next 30 minutes or so, I give you a quick little updates on in terms of the state of AI within the University of Pittsburgh School of Medicine, what we're currently doing, and where is our future direction heading. And then happy to answer any questions that arise after this. I do have some disclosures to note. Some of the stuff that I will show you have been products of mine from various other places that I've been at University of California, most recently Cleveland Clinic. And some of them are Pitt products, like our STAT educational products and our Pitt GPT framework. So as you know, AI is starting to have a big wave of effect on various industries. Many of you probably have been using AI for various things. You may not even know it, and you've been using them. For example, if you use your email, your spam versus no spam filtering classification, that's our classic classification machine learning platform that's integrated in nearly every email system that we know of. But there's lots of other stuff that you use machine learning for, including Siri, Alexa, you name it. And the most recent one that has gotten everybody excited is ChatGPT. And this is basically a chat bot. If you haven't played with it, you can go and play with it, where you can ask it questions, and almost like a virtual team of various people with PhD expertise who basically help you with various tasks. So exciting, but just at the tipping point of everything else that's being integrated within our health space. So given the need for this AI integration within our landscape, we're now in the process of building out an AI division or institute, if you will, that its main focus is going to be the following. One will be around making us a premier institution in education and AI literacy. So education is going to be central to everything we do. Obviously, that AI institute will also be able to help with medical school and other health science operations and needs. And lastly, but just as importantly as the other two, is how do we create an environment where our students, both different students from various health science disciplines, can actually have access to these tools and integrate them and keep them at the cutting edge of science while integrating these technology tools. So as you can imagine, these could help drive future grants and other, studies that faculty may be leading. So very much a complementary way of our AI resources helping the entire system as a whole, as I'll dig into this and give you more granularity as we go on. So how do we become an institution for AI in healthcare, like being the premier institution in AI in healthcare? It's no simple task. We have to provide an AI environment that's second to none. So we'll have to have the latest, greatest, but also proven, validated frameworks that are reliable and can be used within various setups. But just as I was mentioning earlier, we also have to be able to provide unique educational offerings and resources all under the same umbrella that can handle various data set tasks. So regardless of what the student or investigator or whoever may be, this framework will be able to address their tabular data needs, image data needs, text data needs, whatever that may be. But I'll start off, our big picture in terms of our upcoming plans are pretty simple. We're concentrating initially on education in a three-phase curriculum approach. And this is starting off with 14 review article series as its core references, 7 of which, full disclosure, have been those that I had used at the Cleveland Clinic for the course I deployed there. And we're building out 7 more review articles that are updated with the latest, greatest that has been happening in the past couple of years. And these are going to be integrated with various AI tools that will enable the students and the users' experience to be further enhanced as they tackle this space within these various educational labs. Besides the education piece, we're also in the process of forming the framework for our operational plans and assessments and enhancements. And that includes tools that could identify students who may be at risk, that may need to be intervening earlier and helping them with maybe they may not be able to pass their USMLE based on predictive analytics or whatnot. How do we help our internal operational folks with scheduling, admissions, various other things that are integral part of our day-to-day operational tasks? How do we make that more efficient? And then, as I was mentioning earlier, we also want to build a framework that could encourage more people to come to the table, setting us up as one of the premier places that integrates AI in various research plans that people may have in mind. And so with seed funds, AI resources in place. So I'll start off with our AI education plan, since that's central to everything we're doing. The reason I think this is so central is because as you can imagine, about 40, 50 years ago, if you're wondering why everybody needs to learn AI, this is my argument to that, which is that about 40 to 50 years ago, your typical tumor board might have had a hemonc doc and a pathologist maybe. And obviously we know what has happened since, right? Your typical tumor board and other medical multidisciplinary teams are now a mix of various medical professionals that are at the table to take care of the patient as one big unit. So you have your hemonc doc, for example, and a heme tumor board, along with the pathologists, with radiologists, with dietitians, pharmacists, social worker, nurse practitioners. Again, you can imagine lots of people needed to make sure that we have a concise way to make sure we can manage these patients who have complex needs, as you know. But the one thing that's missing within this group of people is, especially now that we're integrating triage, decision support, predictive analytics, and AI tools, is there are no data science specialists within these multidisciplinary teams as they're managing patients. So we're kind of taking the word of AI, as it is, without really having anyone with an expertise in it to be able to chime in, to maybe able to say that, knowing about their limitations as these AI tools may be affecting various, therapy plans or diagnostic plans moving forward. So as you can imagine, this is the next wave of what's coming through. So it will be our job to make sure that we are creating the most AI literate healthcare providers in our landscape. And I would even argue this should be done everywhere globally, because what we do here should be something that others emulate. So how do we actually get more people to the table and get them to actually learn AI? That's the biggest challenge, because typically when people think of AI in education, they think about coding, they think about heavy mathematics, and that may be true for building these frameworks, but the usage and understanding their limitations doesn't require those things, as we've noticed within our Cleveland Clinic experience. So our democratization of AI ML through this three-phase process incorporates those ideas. So in our 2024 plans, which we've just completed actually, all of our students are going to get 3 lessons, just big picture lessons around what is AI as a whole. And these are complemented actually with podcasts that are short and concise so that they don't interfere with the students' busy schedules. So imagine 10 to 15-minute audio podcasts that actually highlight these lessons as well, as they learn about big picture terminologies. What is AI as a whole? What are the things that they should be aware of? Just the basic language so that they can speak to their data science, enabled physicians or even data science teams as they're doing clinical care or research. But the one that we like to emphasize on, and this is kind of like an enhanced version of our Cleveland Clinic version that we had made live, and this is coming in late 25, is our updated elective in AI, and it's about 20 to 25 hours long, a fully interactive, self-paced video series, of course, with embedded interactive apps, which I'll show you some of them. And most importantly, it requires no machine learning and no programming whatsoever and no heavy mathematics. But the most important thing is that it gets people engaged within this space, within this no code environment. So this way it becomes more around people learning the space, understanding its limitations, and also understand its capabilities so that it can encourage more studies and become a way for us to stimulate more AI studies, if you will. So about ideas more than the actual tools themselves. And then for a smaller subset of the folks who may want to actually become programmers and developers, we will offer workshops as well, along with partnerships with other departments like computational biology and others, who basically will teach folks how to actually be part of the build team within this space as well. So as you can see, the first 2 in 2024 and 2025 require no coding, no software engineering background. It's just around people understanding the AI space, and I would encourage more and more people, and hopefully a lot of people will take the elective that would basically then force multiply our AI champions that we desperately need. So the key points around that elective course, since that's the star of this whole education package, is that it, as I was saying, it requires no coding whatsoever, no software engineering whatsoever. It requires no machine learning at all. It's made for everyone, so it's truly democratizing AI education for everyone. And its secret sauce, in order for it to be able to do that, is the incorporation of automated machine learning platforms, or what we call auto MLs, and then along with interactive elements that I'll show you some example of, so interactive applications. So exactly what are these automated machine learning platforms, and how do they help us teach what we want to teach? Because in the first 30 minutes of that elective course, what people are going to basically do and see is how easy it is to actually build the machine learning models with automated machine learning frameworks, just with a few clicks. So we get them excited in the first 30 minutes to show how easy it is to build these things, both, let's say, vision models or tabular data models, as I'll show you in a second. But the other 95% of the course, or the vast majority of it, is going to be around how to do it the right way, making sure they understand best practices around study design, limitations on statistics, a brush up on their statistics, biases, regulatory framework, ethical frameworks, all of them incorporated within that elective course that will follow suit. But exactly what are these auto MLs that will get people excited in the very beginning and keep them engaged? I'll show you the first one through Milo as an example. So for example, the students will be given data sets, and the data sets will like something like this, where it's a data set of diabetic patients. Some of them, and this one is a synthetic one, as you can see, diabetes S synthetic. So they will basically know these are the diabetic positive cases, patients. Each row represents different patients or pseudo patients in this case, and with various features that they have. So, and then the machine basically learns patterns of which combinations of polyuria, polydipsia, weakness, so on and so forth, combined together matches a diabetic patient versus a non-diabetic patient. And you can imagine this doesn't have to be diabetes. This could be for cancer. This could be for sepsis. It could be for a lot of different things. And we do this all the time. So exactly how does this work in real life within the machine learning platform? It's a free tool that they can use called Milo. And they automatically upload through this 4-step process their data sets that are been given. So in this case here, I'm going to upload a few data sets. So the training initial validation data set is uploaded. So if they can attach a file into an email, they can work within this framework. It's that easy. And then they put in the secondary generalization test set. So this way they have 2 separate testing. And then they pick the target of interest. In this case here was diabetes, to see if they can basically build something that can predict future diabetic patients from now. And then what it does, it goes to the second step and shows gold standard data science 101 best practices, typical graphical and mathematical univariate analysis, just to see if everything matches. And then once they've done that, they go to the third step where they actually now build the machine learning models. And for the sake of time, I'm just confining it to k-nearest neighbor, logistic regression, and naive Bayes with various features where we can now basically build this pipeline of various tools that are different processes that are actually build our machine learning models. And you can see the individual spokes of the wheels represent individual pipelines with the different algorithms. So a logistic regression algorithm with various feature selectors and whatnot, that ultimately at the end, these will give rise to over 10,000 models that are been compared to each other. So the user can kind of see which one happens to be the best one, and the ones that I'm highlighting in the table below match the graphical representations above. They can also see exactly what pipelines they've run with, the details of each one. We built 11,000 models within that run, exactly how many was brought in the initial test set, how many in the secondary test set. You can also start deploying them and start testing them immediately. Again, it keeps the user engaged, and they can see what they've built is actually something they can start using. And then they can also learn about the statistical performance measures, their limitations, you can see on the right side. But I can put in somebody who just has a hypothetical positive case. You can see it quickly gives me the answer. You can also do batch testing, so on if there was a clinical trial and whatnot. So again, gets the user engaged. That's the goal number one as they start learning the rest of it, which is the other 95%. Similar thing is true with image-based platforms. We showed them how easy it is to build image-based platforms. And for the sake of thing, I took this in a cafeteria that just has pictures of myself with and without a mask. And I basically now I'm going to train a model to basically recognize me with and without a mask, just to show. And this could be cancer with no cancer or radiology images. Doesn't matter what you have in here. And so in this case here, now the model has learned me with a mask and me without a mask. And it looks like based on its testing, it's doing a good job, defining them. I can open up my camera right now and now quickly take a live picture of myself with and without a mask. And so I start off a picture of myself without a mask, and the model immediately says, you don't have a mask. And with this kind of a confidence, the 84%. And I can also do one with a mask. And again, the model will be able to do the similar thing. It would be able to make a call and says, in this case here, you're masked. And with maybe not as good of a confidence, but again, I only had 23 pictures on each one. So if I increase them, that would get better. But this is just to show you that building the models is not as difficult as it used to be. It's much more simpler than before. We now use AutoML tools to be able to expedite these. Now it's around the ideas, around expediting this space so that the great ideas that all of our students and faculty can have can actually be brought up at a different phase. To complement these courses, as I was mentioning to you, we have our already published review articles, but along with 7 new ones that are going to be complicating complementing the current elective to come. And the new one that's coming out, which a couple of them are already out already in proof version of it, is very simple. Is that it's going to be a 7-part review article journey with starting with an introduction where they learn about a few hundred terminologies with definitions and examples in healthcare space in the introduction to AI ML. Then they understand what is generative AI, like ChatGPT and other things, non-generative AI, statistics in AI and their limitations within both frameworks, generative and non-generative, and then regulatory aspects, both within US and outside of US, along with ethical bias considerations, and how do we deploy these models and keep track of them and update them as they go through this whole process. So it ends up being a relatively comprehensive journey with over 50 AI experts that we've recruited from across the country to contribute to this. Besides that, we also have unique interactive applications built, about 30 of them, when the course goes live at the end of the year. And this is where instead of teaching concepts, especially more elaborate concepts, with just through static PowerPoint slides, we can now include interactive apps where the students can actually be engaged within the process of learning things. So this is an example of cluster analysis for example, k-means. And within this platform, you basically can now just upload, your k-means values of 3 clusters versus 4 clusters, and it will show them how the centroids are built. And obviously 4 clusters is a better thing. Even visually, you can see that. But they can kind of see not only how the centroids are built, but more importantly, how do they match to various mathematical comparisons, like your silhouette score or your inertia values and so on and so forth. So again, it enriches the learning experience as they learn the various concepts. In this case here, happened to be an unsupervised learning process in k-means. So that was a little glimpse of our interactive educational tools in action that will be integrated in the courses. Besides that, we also have major community outreach efforts. And I do like to highlight one that we've done through our own AI center at CPACE, where we've partnered up with our school, SHRS school within the health sciences, along with IEEE Computer Society, and basically a way for high school students, especially from those who with limited resources, can learn various tasks within the AI space. And so this is, we're going to be going into the 3rd year of this next year, and we're hoping that we can provide even computers to those who don't have those resources, that their engagement stays propagated as they leave the course. So that was a quick glimpse of our educational efforts in AI. Now, I'd like to touch base quickly on our current and future operational and research AI needs within the school as well. So as you know, operations within the school, AI can dramatically expedite many of our operational needs, both by incorporating generative AI and non-generative AI tasks. And those are, various things that we can bring on. So building up a team that can provide a resource for the entire health science space, that would be a major task to achieve. And our generative AI tasks, for example, things that we can do is, I'll give you an example. We have our solution, Pitt GPT-2, that can actually provide customized chatbots to our various sections. So instead of you asking your question from your chat, let's say a chatbot like ChatGPT, where it's very general chatbot and may not know your space well and will hallucinate, we can customize our own local chatbot. And by having a local chatbot, you basically now enhance data security, and also IP security issues are maintained through ways that we can customize them, like RAG or multi-agent frameworks, which we've developed, that basically can, in short, can help you ask questions from your local data files. So basically it becomes, if you will, a localized ChatGPT for you. That's very powerful within your own space. And of course, I do blood cancer diagnostics work. So given that I'm in the hematology world, I'll show you an example of how this works within that. If you notice right there, I put a red box showing you that there is no internet connection. I'm running this whole Pitt GPT framework on my laptop right now with no internet connection. So it's 100% confined and secure. And exactly how will this work is it basically will only, it's set up to only talk to my document. So I can upload several hundred documents that are within my space. Let's say I'm only going to do 2 for the sake of this example, one from Fellini's B-cell lymphoma leukemia. And since I also do, again, hematology world, I'm going to pull up the ICC paper from Dan Arbor with WHO and ICC, again, around hematology work. So if I ask it hematology questions, it will be able to do a good job on that. But if I ask it now something that has nothing to do with hematology, like who are the best soccer players in the world, since I'm a big soccer fan, well, obviously I did not pull up a file that had anything to do with soccer, so this will not be able to tell me anything about soccer, and it shouldn't, versus ChatGPT will hallucinate. And it says, I don't know, since the query was outside of your knowledge. Now, if I bring in best soccer players in the world and upload them and ask it the same question, now it will be able to dig into that file and tell me who they are. And it does. It says Messi, Ronaldo, Salah, Mbappe, and everybody leaves me out of it. So I make sure that that's brought into Rashidi. So, but kidding aside, that also emphasizes the fact that the data drives how these things actually are managed. So the right data gives you the right results. The wrong data and the wrong models, as you can see right here, could also give you the wrong results. But if you bring in the right model that's fine-tuned for this, like the Human 22G, and ask it that same question in hematology, which was a CLL-SLL case for someone, and it does a much better job. It gives me the right answer. It says it's chronic lymphocytic leukemia lymphoma, and it gives me the right table. So it actually understands my space within my subspecialty. Again, for different subspecialties or maybe operational needs, maybe different needs. But this is just a glimpse of how a customized framework could actually help with accuracy and various other needs. So we do this because you reduce hallucinations and biases as well. So it becomes more accurate. It's more cost effective because there is no API call to an outside entity that charges you API costs. So it's a local thing, and scalable, more scalable, has more enhanced control and data governance capabilities. And also, just as most importantly, is data security is enhanced since it's local with a no cloud platform. It will be a private cloud, if anything. So last but certainly not least is AI research. And this is AI research for our students and faculty. So having a collective AI environment that provides all student faculty, their mentors, along with the staff to an easy to navigate plug and play landscape in AI and resources. That way, the students access to all AutoML tools and the type of frameworks that may actually enhance their study that they have in mind. So it sets them apart from other folks who may be competing with, for example, for a particular grant. So that kind of a seed funds along with these resources can further set us apart as Pitt as a community, as our folks basically further enhance their cutting edge studies. So how do we scale and get all of this done and next steps? So obviously our infrastructure building, that's what we're doing right now with our, setting up our hardware and software infrastructure and various groups to be able to drive these, along with our AI curriculum group. And now we have our AI Institute work group, and also School of Medicine AI Governance Committee, along with the Health Science Governance Committee to come. But all of this is only possible with all the partnerships and collaborations and continued supports that we've had from our own Pitt community and obviously from our alumni that have been so grateful, so great to speak, interact with. And we're very grateful for all their support as they move this project and many things like it forward. So that kind of ends up my big picture overview. I hope you enjoyed the big picture, and I'm happy to take any questions that you have.
Great. Thank you so much, Dr. Rashidi. We did have a few questions come in during your presentation.
Yeah.
So one of the first questions is, when training models which may play a role in recommending patient treatment, How are you guarding against introducing bias, which may impact those treatment recommendations?
Yeah, as I was mentioning, so the first and foremost, the AI studies cannot but be done in a vacuum. So that's a very good point. So by no means I'm suggesting that, we build a framework and that just enables one person to be able to do something that usually required a group of people to bring to the table. So the multidisciplinary approach to a study does not go away. It's just that the study gets expedited. So to your point, yes, you have to minimize bias. You have to make sure the right expertise are at the table, given also that our world has inter-observer variabilities even within different disciplines that we have. So we want to make sure that not just one healthcare expert is involved, but multiple. So all of these will enable the final model to improve in its capabilities. But the take-home point of all of this is hopefully this environment and the educational platforms enables more and more transparent and easier crosstalk between the different groups that are typically trying to talk to each other. So how do we, force multiply our AI champions, increase the number of bridges that are currently in place or want to be in place? So yes, to their point, absolutely. This is not to replace multidisciplinary collaborations and studies. This is just to complement those that are already in place and will be in place by educating those so that everybody understands about each other's limitations, if they will, and strengths.
Thank you so much. A second question is, with the recent news about insurance companies using AI to deny treatment coverage, is there a role for AI by the doctors in supporting their treatment recommendations to counter that?
Yeah, that's a great question. I have to say I don't have a perfect answer for that in terms of, how do you counter some of this? How do is there a quick fix around it? I don't have a quick fix. I don't know if anybody does. But one thing that I have seen that people have already used is, for example, I have seen people using AI tools at several institutions that are trying to basically, like, for example, when a claim gets denied, the doctor is able to use an AI tool to quickly write up the appeal, and be able to ask for, re-review, for example. So I think that kind of a back and forth between the providers and the payers, that's both of them are already starting to use these frameworks. I don't think that interaction is going to go away. I do think that we need to be cognizant of the fact that some of this information could adversely affect our patients as well. And we would have to put in, the right frameworks and the right regulations and policies in place that those things do not come back and hurt our current workflow space. But I'm also realistic. I know just living within this kind of a system, that is always a back and forth that's happening between the providers and the payers. Hopefully AI will not just become a way to, if you will, fight back, but a way for us to coordinate better so that the the delivery of the healthcare as a community and as a society becomes optimized over time with with less hurdles, if you will. But that's a big if, and I'm being realistic, so I'm not sure how realistic and how, because there's just so many other forces involved in this thing, economically as well. So, but yeah, that's a very difficult question to ask. But I do, going back to the original question, is that yes, we are using AI to help expedite some of these processes that, for example, payers are starting to incorporate in their systems.
Great, thank you. Another question, although AI is important, how does one maintain that MD-PT interaction without permitting the AI input, removing that?
Yeah, that's huge. I think first and foremost, I think we should think about these as just assistants. So they're not there to replace us. I think there is definitely a shortage in all sorts of healthcare subspecialties, in both physicians and other providers. And so I kind of see this as a way for us to use a tool that helps us with the more mundane automated tasks, and actually does the opposite. It leaves us more time to kind of go back to the old ways where you had time to talk to your patients. Right now, without the use of AI, what we call pajama time, which I don't necessarily love that term, but it's where the clinicians, when they finish their regular workload, as many of you know, they go home and they're up till 10, 11 o'clock at night signing out their cases and their notes. And so I can see AI shortening that pajama time. That's something that I'm not the only one who says this. Lots of people seen ways that pajama time could be decreased. That would be for better health and well-being of our caregivers. And then secondarily, the same thing is if during the clinic, these things can expedite certain tasks that are mundane and automated, and typically the physician is doing or another clinician is doing, tools as such can leave more room for the physician can do what they're made to do, is to actually interact with the patient more. And I think I'm pretty optimistic that these tools will help us with those tasks. But I'm also realistic. There are going to be certain tasks that currently clinical caregivers are giving that the AI tool will become better and better with time. And then, but at the end of the day, I think, as long as we keep a human in the loop approach, that the AI is not making the final call and we're the ones who are reviewing them. I think that's the safest approach forward, in most cases. And I would say probably 99% of cases. So I would say my own view of it is I kind of see these things as assistants. You can kind of think about them as, some people that refer to them as digital fellows. So if your regular fellow or your resident had written up your notes or had helped with a workup of a patient, of course, you as the caregiver would still be involved and engaged in terms of wanting to do the final review. Kind of these would be kind of in the same camp in my head, but more of a virtual version of it. But I agree. I think human in the loop is a must and has to stay as a must.
Another question is, with the use of RAG, there is a significant role for private data sets. What are your thoughts about sharing these data sets across multiple institutions? Are there privacy implications?
Yeah, that's a great point. So I didn't get a chance to. So my own expertise is on synthetic data and auto MLs, and so I didn't get a chance to show you my own research work for obvious reasons because of the theme here. But yes, it's true. It's not easy to share data from one center to another. There's all sorts of data security risks and quite frank, lots of regulatory hurdles to overcome, with material transfer agreements and whatnot, which most people don't want to go through that. So I think kind of like learning from other disciplines outside of healthcare and making use of synthetic data to complement real data, that could be a great way to minimize some of these issues. So, and we are tabbing in getting into that space for the past several years. So this is like, other ways that people have framed them is like digital twins. Basically, it's the synthetic data world. And generative AI, like things like ChatGPT, are under that synthetic data world. But besides text data being synthetic, we also now have image data that can improve our performances of our models that could be synthetic. So mixing and matching synthetic with real data and see how the model improves. Same thing with tabular data. We could create digital twins of the EMR and have fake EMR, patients that may enhance the real one's performance. Or when data security transference is an issue, there could be a way for you to be able to transfer data easier because the regulatory oversight will be less. So yeah, there's lots of things around the synthetic data world that I think should be incorporated within either the RAG or the non-RAG types frameworks. But yeah, I think we should make use of as many of the responsible tools that we have after we've seen that they've provided the right guided, validated framework. Right now, we're in the infancy stage of a lot of these things. So I think our jobs as scientists and caregivers is to make sure that we build a framework that's validated, it's reproducible, but at the same time, can move the needle forward and make an impact in not only research, but patient care eventually.
Thank you. We do have a few more questions that came in as well. So the next question would be, would you please share more about what you have in mind for supporting students in reaching their academic goals, such as predicting and preventing struggles on USMLE testing?
Yeah, that's a good point. So that's actually dear to my heart, actually, because so we had built a USMLE predictor tool about when I was at University of California, and it started got before COVID. They were using it internally actually, and this was a way to be able to identify students who may be at risk of not passing their USMLE step one. Now people are using them for step two as well. We definitely want to incorporate things like that so that we can kind of have a better sense of, where our students are going. And quite frank, these are not what we did. University of Indiana follows suit, and they actually have a live model of it that they are using within that same USMLE predictor kind of like thing, and the students get to see them. I don't know exactly what the final decision will be internally in terms of how much the tools will be interacting with the students directly, how much of them will be behind the scenes to help administratively kind of guide the process forward. That's stuff that we will have to look at internally and see how that fits in within Pitt's framework. But yes, we definitely would want to incorporate some of these things that helps operational stuff, helps with scheduling, helps with USMLE score tracking, helps with residency matching, so on and so forth. And then this could also be before medical school. So we could try to see, are we, tapping into the right pools of folks as we're, filling up our medical student classes, can we do a better job in some of these things? Can we do a more expedited job, And so, yeah, I think lots of these things are in place that we could use AI to kind of I hope that answered it,
Thank you. Next question, how do you balance the need for transparency, for example, visibility into the black boxes, and the desire to reduce the need to high-level IT, ML, AI skills?
Yeah, so that's a good point. That question has come up for me before. So I have to say, my own view of it is pretty simple. So first off, I think to the black box issue, yes, it's very true that the deep learning or deep neural networks that we're using for various image and let's say ChatGPT type stuff, we don't really understand the inner workings really well. There is no transparency there. Nobody does. And so the question is, so just because we don't understand them, should we not use them? And that's for me, I'm not in that world. And the reason I argue against that is because I think if you had two algorithms, let's say a deep learning and let's say a more transparent one like logistic regression, and they both perform similarly, then yes, of course, we'll use the simpler, more transparent one. But I think it's not in the best interest of our students and our patients if we know we have a model that actually outperforms a more traditional model quite a bit, to not use it just because we don't understand the inner workings. And the way I argue that typically is because these things are kind of like mimicking the human brain. I actually had this happen during a conference call, which was, or it was actually in person, where the person specifically said they can't trust our deep learning platforms because they're not transparent, they're black boxes, and until they truly understand their workings, they can't really start using them. And my question to them was, I asked them a very simple question, which was, what color is the chair that's next to you, and the chair's backing was orange in color or red. And this gentleman said, it's orange. And I said, well, I'm sorry, until you tell me which neuron in your brain specifically connected with which other neuron, and to give you the color orange, I can't take your word for it either. So I think for the same reason, we do take another human's word because they say something was orange or green or blue because they saw it and they managed it in their brain, because there is reproducibility there, because multiple other humans will agree with that happens to be orange. Same thing is with the neural networks. If we get them to be statistically reliable and they show inwards and outwards that the secondary, tertiary, quaternary test sets are showing similar reliabilities, then we're actually doing a harm by not using them. So I think understanding them is important. Hopefully over time we will. But if we don't understand them, but it's still benefiting our society and benefiting our patients and our users and our students, not using them could be more detrimental than using them. So that's my 2 cents. Not everybody agrees with this, by the way. So I know that's that's kind of like a hot topic, but my view of these is using them as a way, if they are showing statistical reliability and they are shown to be human in the loop process throughout that basically has validations, then in my head, I don't see a reason not wanting to use them. And so that's my 2 cents on deep learning black box phenomena.
Thank you so much. So we have time for about 2 more questions.
Sure.
Our next question is, what small language model framework are you using for Pitt GPT to be able to run on laptop class hardware, Llama, etc.?
Yeah, so I don't use a small language model. I actually have a quantized large language model. Yeah, I mean, we do have small language models too, but Pitt GPT's framework is running on a fine-tuned a mixture of agents framework, large language model. We do have also a Llama, version of it too, which is actually not quantized. The laptops that I meant that I'm using, they are, to be fair, they are more powerful than most people's desktops. And, it's almost like a mini high performance computing platform. It has 128 gigabytes of RAM. So it's not like the run of the mill laptop that most people have. So I'm not suggesting that people should be running these on their laptops. That was just to showing that the demonstration I showed was done on my laptop, but the ones that we will be running will be done through our high performance computing platforms, because they will run much faster than a laptop with if I had the right H200 set up on the GPU rather than running it on a MacBook. So I hope that explained it. I mean, I apologize if I gave the impression that I'm recommending using these through laptops. That was not my intent. I just showed that as a way to show that I ran it locally.
Thank you. So last question, before we wrap up today's presentation. In some cases, these AI ML tools will meet the FDA's definition of a medical device. For those students and faculty who will be working on such products, will the FDA's quality system regulations be part of the training curriculum?
Yeah, so I'm glad you asked that. So we actually just finished. Actually, it was just published. So I recommend you all Googling regulatory AI and put in my last name, and you'll see the paper. That's actually one of the papers out of the 7 that I said that's actually already out. And we do talk about exactly what you just asked, which was about the various FDA frameworks and even other countries' regulatory frameworks and AI. There's still lots to decipher within how these things pan out. As a general rule, I like to and we do, through our national committees, we do advise some of these regulatory frameworks. So in my head, I usually like to group things into 2 major groups, specifically generative AI and non-generative predictive analytics AI or machine learning tools, is because I think having extra hurdles under one big giant umbrella of AI that includes both generative and non-generative, it actually will hurt the non-generative, traditional machine learning platforms that we have that are part of our day-to-day operations, actually. So the last thing we would want to do is to put additional hurdles that slow us down for things that are part of our triage. But I definitely agree that the generative AI framework needs its own set of regulatory frameworks, because as you can imagine, if you spit out a whole page of something, the performance measure is not the same as like a classification task that says something was cancer versus no cancer. Because you can change in a full text of an entire page or a paragraph, the tiniest word change could change the entire context of the whole thing. So yeah, I definitely see generative AI needing its own kind of oversight, but that landscape is also has lots of landmines in it. So there is obviously SAMDs, the software as a medical device, that various things could fall under that. But besides that, I think people are now also starting to think, could some of these frameworks fall under the LDT frameworks, which is our laboratory developed tests, or are they LDT-like, where if you do a homebrewed setup, will FDA have oversight over that too? Because up to this point, a lot of these things were seen as more like advanced calculators. But you're right, I think they're way more than that, and they should be seen more like tests, like another laboratory tests. And so yes, there should be definitely the right amount of regulatory framework around them, but I think it also should be done in a very responsible way and not gestalt done as one umbrella all under everything. I think it should be separated out, have the right expertise, driving the different folks forward. So I don't know what's going to happen in the next few years. I'm hopeful that our regulatory folks are going to be receptive to our inputs, and they will help with regulating our generative AI framework without really adding lots of hurdles in our non-generative AI frameworks. Also realizing that probably the future is going to be a combination of everything, like multimodals, right, and multi-agents, where the generative AI frameworks or agents like as such will become the orchestrators of both generative AI and non-generative AI, where that's going to be probably the future. But until that happens, yeah, lots of, steps to overcome and hurdles to overcome.
Great. Thank you so much. And thank you so much for taking the time and addressing all of those great questions from our audience. And thank you for your presentation today. It was great. Thank you to our audience for being here today and also participating in the discussion. That does conclude our program, and have a wonderful afternoon.
Yeah, thank you all. Thanks for being here, and hope to meet some of you in person sometime. So thank you so much. Bye-bye.
Thank you.
Thanks.